Our focus today for Chem 2 is to finish up Chapter 8 in review, and we're going to talk about formulas of compounds, empirical formulas, and molecular formulas today. So just a quick review to remind you that an empirical formula is your smallest whole number ratio for a formula, and your molecular formula is going to be a multiple of the empirical formula. So in this case, our empirical formula was CH, that's a 1-to-1 ratio. If we take and multiply both subscripts by the integer 6, we get C6H6, which is the actual formula of the compound, not just the CH. That's just the simplest whole number ratio. Let's go through steps about how to calculate empirical formulas, and then we'll do an example. Okay, this example reads, a gaseous compound containing carbon and hydrogen was analyzed and found to consist of 83.65% carbon by mass, and wants us to determine the empirical formula of the compound. One of the things I want to bring out is that the first thing we have to do is get the mass of each element. But the fact that they give us a percent composition doesn't need to throw us off, because we can assume that if it's 83.65%, just like if that were a test score and it was 100 points possible, you would have 83.65 points out of 100. We're going to assume that's 83.65 grams out of 100 grams. And in order to get the amount of hydrogen, we just subtract the 83.65 from 100, and we get 16.35%, or 16.35 grams of hydrogen. Step number 2, we're going to determine the number of moles of each atom present, and this is just by using the atomic masses from the periodic table and changing grams to moles. That's all we've done. Step 3, you're going to divide the number of moles of each element by the smallest number of moles to convert the smallest number to 1. So in this case, my smallest number of moles is carbon, 6.965, and I divide 6.965 by itself and get 1. But when I divide 6.965 into 16.22, we don't get a whole number. We get a decimal number, so 2.33. So that leads us to the next step. We have to make sure that all the numbers have our whole numbers, and in order to do that, we have to multiply the numbers that we get by the smallest integer that's going to allow them to become whole numbers. So in this case, if I multiply 2.33, which was our problem, it wasn't close to a whole number, by 3, I get 7. So I can do that, but I have to, whatever I multiply this one by, I have to multiply all of them by. So the carbon gets multiplied by 3 as well. So the empirical formula, or the lowest whole number ratio for this compound, is C3H7. Okay, let's work through one together. This says the composition of adipic acid is 49.3% carbon. And that, remember, is going to be 49.3 grams. So it's 6.9% hydrogen, and it's 43.8% oxygen by mass. So those percentages we're going to write down as a mass, as grams. The next thing we're going to do is change them to moles. So the first one's carbon. Carbon has a mass of 12.01 grams in 1 mole. That's straight from the periodic table. Hydrogen for 1 mole is 1.01 grams. And oxygen is going to be 16 grams per 1 mole. Let's do the math on that. So 49.3 divided by 12.01 is going to come up to 4.1049. And let's try to keep 4 to 5 places past the decimal on these. And this is moles of carbon. The next one, 6.9 divided by 1.01 is going to be 6.8317 moles of hydrogen. And the last one, 43.8 divided by 16 is going to be 2.7375 moles of oxygen. Now we have to look at it and determine which one of these numbers is the smallest number, and it's the number of moles of oxygen. So I'm going to divide each one of these by the number of moles of oxygen, because that's going to give us a lowest whole number ratio of 1 for oxygen. So draw through here and write this out. You may be familiar enough with these to be able to not have to write the division sign and things like that. It's just up to you. Okay, so let's start with the carbon, 4.1049, and divide it by 2.7375, and I get 1.499 or 1.5. I take hydrogen, 6.8317, and divide it by 2.7375, and I come up with 2.49 or 2.5. Now my problem is this is not a whole number ratio. We don't have whole numbers out here, and they're not extremely close to a whole number, so we have to multiply these by something that's going to give us a whole number. Well, we know just because we have done algebra for so long that it's 0.5, so if I multiply it by 2, I'm going to get a whole number. So multiplying 1.5 times 2 will give me 3, 2.5 times 2 will give me 5, and whatever I do to 1, I have to do to all, so that's going to give me 2. So those are our subscripts, C3H5O2. Okay, once you know how to do the empirical formula, the hard stuff's out of the way. With the molecular formula, which is the exact formula it's going to exist in, all you have to know is what the molecular mass is. And that's always going to be given. So if we look at this one, it says a gaseous compound containing a carbon and hydrogen was analyzed and found to consist of 83.65% carbon by mass. The molar mass of the compound is 86.2 grams per mole. You already determined that the empirical formula is C3H7. What's the molecular formula of the compound? So in order to do this, all you're going to do is start with calculating what the empirical mass is. So we're going to calculate the empirical mass. So I have 3 carbon times 12.01, which is going to be 36.03. And I have 7 hydrogen, which is 1.01. And that's going to be a total of 7.07. We're going to add that up. And it's going to be 43.10 grams per mole is what the empirical mass is. Okay, so in order to get the multiplier that we need, the integer we need to determine molecular formula, we're going to take the molecular mass and divide it by the empirical mass. So they're always going to give us the molecular mass, so it's 86.2, and we're going to divide that by the empirical mass, which is 43.1, and this ends up being 2. And this is always going to be a whole number when you do this division. So this is our multiplier. So while our empirical formula was C3H7, I multiply both of those subscripts times 2, and my molecular formula then is going to be C6H14. And that's my molecular formula, which is twice as heavy as what my empirical formula is. Now, the best thing we can do is take some time and practice these types of problems.